Like any other programming language, after knowing how to define variables and what are the types, functions, structures, etc., need to learn how to use them to direct or control a program using control structures. In this video, I'm going to show what are the control structure and how to use them in Golang. But first, we need to start with the operations. In mathematics and programming, an operator is a character that represents a specific mathematical or logical action or process. In Golang, the operators are divided into 6 categories. The first category is arithmetics. Arithmetics, such as addition, increment, subtraction, decrement, multiplication, division, and remainder. Arithmetic operations are the operations that involve mathematical calculation on numeric data types, such as both signed and unsigned integer, floating points, and complex numbers. But it isn't true for all data types and operations. Some arithmetic operations are not defined for the complex 64 or complex 128 types. Another example is modulus for floating points. The modulus operator isn't defined on floating point type. So let's start with the simple operators and see how they behave. So when we want to add two numbers together, like 1 and 2, we can use the plus sign. And it's simple enough to understand. It's going to add these two numbers together and then print it out. If we want to have subtraction, and same for multiplication, and slash for division, percent for remainder. There are two more operators, which are increment and decrement. When we want to add or increase a value by 1, obviously we can use plus 1, but we can achieve the same thing using double plus sign. And then when we print it out, the value is increased. And we have the same behavior if we have minus minus. So if we run this, we'll see we got minus 1. The second category of operators are comparison operators. The comparison operators are used to compare two values and return a Boolean result, either true or false. So let's say we have x and y as integer. We want to compare two values together to check whether they're equal or not. We can use double equal. So this is going to check value x and value y and return a result in Boolean whether they are equal or not. We get true because both of them are 0 when we define them. Now if we want to check whether these variables are not having the same value, we can use exclamation equal and the result will be false. Now let's say we increment value x. So if we want to check whether x is greater than y or less than y. So to do so, we can have x greater than y. If we want to check whether x less than y, we should get false. There is another operator that can check two conditions at once, which is less than equal or greater than equal. If we have a condition that requires to accept values above 3, including the 3, we can do this like x less than equal y. So when we run this, we will get true because it's not less than, but it is equal to y. And we can have the same for less than equal y. It's not less than, but it is equal. So let's change this to 5 to make it more obvious. As you can see, it's not less than or equal to y, but it is greater than or equal y. Logical operators comes from Boolean algebra, which is a branch of mathematics that deals with the logical operators. The concept of Boolean algebra is the use of binary values, which the value can be only 0 or 1, where the 0 known as false and 1 known as true. In programming, logical operators are used to combine two or more conditions of expressions into a single, more complex conditions that can be evaluated to a Boolean value, true or false. Logical AND, which is defined by double ampersand, takes at least two operands. So if we run this, we'll get true because x is equal to 10 and y is equal to 5. The logical OR operator, which uses double type character, has similar characteristics as AND operator, but the results are not. If we have x equal 0 or y equal 5, we will get true in result. That's because the OR operators will return false only if all conditions are false. As you can see, x is not equal to 0, but y is equal to 5. That's why we get true. And now the logical NOT, which uses exclamation character, is used to reverse the logical state of a condition. For example, the result will be false. But if we change to NOT, we will get true because this condition by default is false. But when you use the NOT gate, it will reverse the result. So the false will be true. And then at the end, true and true will be true at the end. Assignment operators are used to assign a value to a variable and also perform some basic operations at the same time. To assign and add some value to the variable at once, we can do x plus equal 4. So we will have 5. We can use the same approach for other basic operators, such as minus equal, asterisk equal, slash equal, or remainder equal. So there are two more categories, which are the bitwise and pointer, which they require separate videos. So I'm going to create another video for the pointers and bitwise. Okay, so now let's talk about the if-else. One of the common and basic control structure that is used most of the time in any programming language is if-else statement. I've categorized the if statement into 4 categories, which is basic if-else, if statement with initialization, and multiple if-else statements. Let's take a look at the basic. The if statement accepts a condition or conditions using logical operators where the output are Boolean. And if the condition is true, some code will execute. Here is an example. So let's say we have x equal true. If x, if we run it, we'll see the code, which is the prompt println, is going to print out x is true because the condition in front of f, which is x, was true. The conditions can be with comparison operators. So we say if y equal 5, we print y. I can just print out the value of the y here. We run it, the y was equal to 5. That's why the code is executed in the scope. If we have another operator like greater than, as you can see, never printed, means that condition was false and the code never executed. Now, if you want to have multiple conditions in the same if statement, we need to use one of the logical operators. So in here, I've combined these two conditions using logical AND operators. So that means the both sides, which is x and y greater than 1, must be true in order to execute this code. As you can see, both are true. We can use else keyword to execute code that need to be run in opposite condition of the if scope. That means if the first condition is false, the code in the else scope will execute without checking any condition. For example, if we have x greater than 3 and we use the else right after closing the curly bracket, so if we run this, we can see that it is not. So the first condition here being checked and it's not true. So without checking any more condition, using else keyword is going to execute the code in the scope. In Go, we can initialize and assign a variable at the same line as the condition. For example, if we have if x colon equal 10, that means we are declaring the x variable and assigning 10 to it. And then with using the semicolon, we can go for the condition, which is x equal 10. So if we run this, we'll say it is true. So that means at the same line of the if condition, we declare x variable and assign 10 to it. And then after semicolon, we're going to check the condition whether x is equal to 10. That looks a bit weird if we declare and assign a variable like this and then check its condition. But this technique is very useful when we want to define and initialize a variable that is only accessible to its scope. Let's say we want to print out the x here. As you can see, the x is not defined. That means after this scope being executed, the x is going to be deallocated. Now we can have unlimited if statement using else if keyword or more conditions. And you can see a is lesser than x. That means this condition being true and execute it. In this case, the first condition is true. It's going to execute the code block and skip the rest. So even though this one is true, it's not going to execute it because it's going to exit from this statement when it's done. You may see parentheses in if statement in other languages, but in Go, parentheses are optional. In multiple conditions, for better readability, some programmers use parentheses. Let's say we have this condition. This is a little bit less readable, but if we use the parentheses, we can make it a little bit more readable. If we want to change the result using not logical, we can use parentheses and exclamation before the parentheses. This can be useful when we using the logical not for some comparison condition. Unlike other programming languages that has while loop, do while, loop, etc., etc., Go has only a one looping construct, the for loop, which starts with the for keyword. We can write for loops in four different models, which are basic, range, conditional, and infinite loop. So let's take a look at the basic form. The basic form of for loop has three components separated by semicolons: the init statement, condition, and post statement. So we start with the for keyword and the init statement where you initialize the variable and assign a value to it. And the second section of that is the condition. We're going to check I less than 10, and then separate with the semicolon, and the post statement going to increment the I by 1, which we're going to define and declare this value once at the beginning of the loop, which is I equals 0. The second component is checking the condition at the beginning of every iteration. So it means when the loop is running, the first iteration was going to check whether I is less than 10 or not. If it's not, it's still continuing. It's still continuing until it's true. Once it's true, it's going to exit the for loop automatically. And the last component execute at the end of each iteration. Once the loop is running, it's going to initialize the I value and check the condition. Once the code in the scope reaches to the bottom of the for loop, it's going to execute the last component, which is increment the I. We can see it's going to print out the values of the I which incremented. So in this example, we have I less than 10, which is not included 10. So if you want to have exactly 10, we can use less than equal. So when we run it, we're going to have 10 iterations here. So we can have a reverse of this loop as well, where, for example, we want to read an array in the reverse order. So let's say we have an array, and then what we need to change in this is the initial value, and the condition that we're going to check is going to be reversed, go to 0, and it should decrease the number. And then go run. As you can see, 4, 3, 2, 1 is printed out. The -1 is because we are using the I value to get the value of the array, and the array is started from 0, while the function len output uses the natural numbers, so which is starting from 1. Now we have for range, used to iterate over slices, arrays, maps, and as well as the strings. The range keyword is going to iterate the loop equal to the length of the given map, slice, or an array. Let's say we have this slice of strings, and if you want to iterate over the length of the slice, what are these two variables that is going to extract from the range keyword? Is that the first I are going to be the index for slices and arrays, and if we have a map, it's going to be the key. And the second one is a v as a value, so always for the slices and maps will be the value. So let me run this. As you can see, the iteration number is 0, 1, 2, and the values are A, B, C. Sometimes we don't need to print out the value of I. So if we remove it, it's going to be only the index. So you see, it will be always the index. But how we can do it only getting the values, so we can use the blank identifier like so. And now when we run this, we can get only the values. So let's say we have a map. So here we can use for k, which is a key, and value, and then range of the map. And then when we print out, will be both keys and values. If you watch my previous videos that I was talking about the types in Go, you know that the strings also is array of bytes. Since the strings are array of bytes, so that means we can iterate over that as well. So let's say we have the string of hello, and now will run. The bytes of this string is going to be printed out. So 101 is going to be uppercase H. So we can convert this. If we run this, you can see HELLO is going to be printed on the output. Now let's talk about conditional for loops. This loop is a bit look like while loop in other languages. Let's say we have var x with the type of int 32-bit, and here we're going to check if x less than equal 10. You can see that it's going to be iterated 10 times. So this loop is going to execute this block of code until this condition turns to false. So as long as it's true, it's going to iterate and execute this block of code. And when the condition gets false, it's going to exit automatically. So the infinite loops are the loops that never stop iterating until we break them based on some conditions. Usually they suggest not to use infinite loop to avoid jamming the CPU usage or eventually crash the program. But here is an example how to define infinite for loop. So it's very simple. We just use the for keyword and open parentheses and close parentheses. So everything in this is going to be executed. In Golang, with help of channels, we can use infinite loops safely. In this case, the loop is not executing the code in its scope as fast as it can. Instead, it's waiting for a signal from the channel to receive on every single iteration. One of the real-world examples is the web server. The web server is opening a port and listening to the incoming connection. So that's an infinite loop that receives the request, then send it to the endpoint. After that, the loop is going to be blocked until the next request arrives. So finally, we need to break the loop in some conditions. To break any for loop, we just need to use break keyword, and this is going to break the loop. So the first iteration is going to be print out the hello string and then break, means exit from it. So in this example, the break is only breaking the loop that is going to be called from inside, which is this line, but not the for loop. So if you run this, as you can see, it's keep going, and never break this until I send the interruption signal. So if you want to break from the main, we need to use the break in the main loop. So if I run this, you can see the first time iterating that and break. So what if we want to have only break here, and after iterating this, we're going to exit from the entire loop? There is a solution for this, which I'm going to cover end of this video. Switch case is another control structure statement. Switch case is very similar to if-else statement, and the outcome, or more or less, is the same. Both check some conditions, and if the condition is satisfied or the result was true, the block of code in their scope will be executed. In general, we can write switch case statement in basic, multiple expression, without expressions, and type stuff. So the basic form of writing the switch case is to use switch keyword, and in front of that is going to be a variable or an expression that you want to add. So let's say we have day, and the day is Monday, and checking the condition is going to use case keyword, and then we're going to add the value. In here, the value of the day is going to be extracted and then check with each of the cases. So the first case is a Monday, and we have the default. The default means if none of those cases are true, so the default will be executed. So if we run this, we'll see today is Monday. With multiple expressions, we can execute a block of code for multiple conditions instead of retype the block of code. Let's say we want to run some code for weekends only. Okay, so in this condition, this case will be satisfied and execute the code. But what if we use another day of the weekend? That means we need to write another one. That's not really clever. So for the multiple expressions, that means we can have multiple of these in the same case. So we can use, if we run this, we can see, yeah, yes, we can. And we can change it to select. And again, we get the same. Another way of using switch is without expression. That means we don't need to specify any variable after switch keyword. Instead, we need to define it in each case. So let's say we have x equal 1 and y equal 5, and we can have switch without any expression, and then case x if greater than y, and another case we can have if x less than y. If we run this, you can see is x is lesser. Also, we can write some Boolean conditions in front of the case, which is a logical operators, exactly like the if statement. Let's say we have a case which says x equal 1 and y greater than 4. And let's see what's the result. So the first condition is going to be true, and then it's going to execute the block of code. This behaves exactly the same as the if else. That means if the first condition is true, it's going to execute the code and then exit from the switch case statement entirely. But in switch case statement, there's another keyword that led us to fall through to the next condition. That means we check this condition. If this condition is true, it's going to execute the block of code and then will fall through to the second case without checking the condition anymore. So in this case, we can use the fall through keyword. If we run this, we'll see that both codes are being executed. Overall, switch and if else works almost the same, but usually if else used for maximum 2 or 3 options, while the switch case used for numerous options. After all, switch case looks nicer and more readable than if else. We have options of move to another code block based on the previous condition using fall through in switch case, which we don't have such thing in if else statement. We have something new compared to other programming languages, which is select. Select only works with channels and blocks the execution until one of its cases, which listening to multiple channels, run, then it executes its code block. Also with select, we can have multiple valid options at once, while in switch case, we only can have one. We can use select in 5 different ways, which I'm going to show it. Basic select syntax is exactly like switch case. So let's say I have a channel. For this, I need to create a channel variable, which I'm using the time package. And let's say we have talk, and then we can have another case. So now let's say we want to listen to a channel in an infinite loop. So let's say, as you can see. So the second approach is to use with initialization. So we can have x equal to tick, and then we can print it out, run it, and as you can see, the value of the channel tick and top is going to be printed out like so. Now let's say we want to have some sort of timeout for the select. Then we can use another method from time package, get a signal every second, and then print out timeout. If we run this, we'll get the timeout, as you can see. So as you know, the channels are blocking by design. So that means it's going to block the code execution until we receive some signals or data. So what if we want to have non-blocking select condition? That means let's take a look at this example. If we run this, we're going to wait until one of these channels are receiving a signal, and then we execute it and then move on to the last line, which is printing out done. So what if we don't want to block the code only for these channels? In this situation, we can use the default keyword. That means it's going to check this channel is receiving anything or no, and then the second channel is receiving anything or no. By default, we're going to run this. So in this case, we're going to have nothing received and done. Also, we can have only default without any code for it. As you can see, it's only the last line is going to be executed. Last but not least is the goto keyword. Goto is a reserved keyword that can transfer control to a label statement. Basically like jumping to the label that is in another part of the source code. Using goto is discouraged in most programming languages as it has potential to create very hard to debug bugs. However, we can use goto in a specific cases. Take a look at this example here. We're having the nested loop and we want to break entirely from the loops when the result of x times y is greater than 50. In this case we use break, but the break is only breaking the child loop but not the main loop, and it still keep going until this for loop is ended. For this situation we can use goto. We need to define a label, so we can define it by the label, by the way, can be anything. Then we use the colon. So in here we can use goto keyword and then type the label after that. So let's run this. As you can see, we skip. And to make it more clear, so what we have after 6 iteration in the main loop, we escape it entirely. So let's see if we have only the break. And you can see the iteration of 9 we escape. That means all the iterations are already done. So that was all for this video, and thanks for watching.